Alrighty, welcome over to day 18 of Advent Code 2020. We're just gonna pretend like yesterday never happened. We're just going to forget about it. We're not going to talk about it. We're just gonna, erase that from our minds. That video doesn't exist. It's just, we're moving on. I don't think we can get any lower than yesterday. So, please just give me something to, we can't do worse than we did yesterday. I mean, I guess we could not get it right, because we did get it right in the end, but at the same time, just... Anyways, day 18 begins right now. As you look out the window and notice a heavily forested continent slowly appear over the horizon, you're interrupted by the child sitting next to you. They're curious if you could help them with their math homework. Great. Unfortunately, it seems like this math follows different rules than you remember. The homework, your puzzle input consists of a series of mixed expressions that consist of addition, multiplication, and parentheses, just like normal math. Parentheses indicate some normal math order of operations. However, the rules of operator precedence has changed. Rather than evaluating multiplication for addition, the operators have the same precedence. They are evaluated left to right regardless of the order in which they appear. For example, steps, you just solve it as is. So parentheses still override this. Okay. Understand yourself. Evaluate the expression in each line of the homework was the sum of the resulting values. Okay, so this is... Wow, that's me a lot. This is actually not too bad. So the way you solve things like this is you just build a tree. Like, that's the solution for any type of hierarchical, order of operation stuff. It's just a tree. The tree is all you do. That's all we need to do. So what we're going to do is we're going to load in each line. We're going to go for string s in input strings, and so you can build a tree, but another way that you can build a tree is actually by just doing recursive loops. So we're going to do this recursively. So we're just going to do public int solve. We're going to give it a string s. Okay, so given a math problem, so there's only left to right to left. So what we need to do is we need to take the first number we're at, we need to then take the operator, and then we need to take the right side. So, yeah, because it is left to right, we just take the operator and then we do addition of the right side. However, if the right side has a parenthesis, we need to solve that parenthesis first, or left case. So, parentheses are going to be the kind of hard thing to deal with, but yeah. So what we're going to do is we're first going to check if s starts with a parenthesis. If it does, we need to solve this a bit differently, because we need to solve the parenthesis first and then go from there. Otherwise, what we're going to do is we're going to do then integer parse int of s dot substring 0 to s dot index of the first space. This will give us our int left. Okay. And then we're going to go, so now we need to solve the right side, because this is left or right. We just need to take the left, and then we need to not solve the right. We only need to do that if the right is a parenthesis. So what we need to do now is we need to first check actually, let's do, breaking this up is going to be interesting. I mean, I could break this up by spaces. Spaces sort of work, they sort of don't. How do I want to sort of break this up to be able to determine the sides and to do order operations? So, okay. So we're just going to adjust the string. So we're just going to do string, we're going to do just a bunch of string map operations. We're going to do a remainder. So first we need to get the int space index here is this. Okay. And then the remainder is going to be s substring from the space index plus 1 on. We're going to trim that just to be safe. So there's the remainder. Okay, there's our left. And now what we need to do is we need to do if the remainder starts with, now we need the sign, or we need the operation. sorry, the operation comes next, right? It's actually just gonna be a char. So operation can only be one character, so that solves that. So we can just do s char at, and we can just do at 0, and then we can just do remainder is going to be. Actually, we don't want to do s anymore. Once we have remainder, we never want to use s. So remainder substring from 2 on. Good, so now we just need to know if now the remainder starts with a parenthesis. Again, we need to do things a bit differently. Otherwise, we can just go ahead and solve the next bit. So we can just do a nice little this again, where we have, again, the space index is going to be the remainder index of the space. Space index, remainder, technically it doesn't need to be set again, but now we have the right, and we can go ahead and do the right here with that. So I'm not building up this tree like I kind of want to. Parentheses make this a bit harder. Yeah, parentheses sort of make this harder, not a ton. It's been a while since I've had to do this type of stuff, so I'm not the most fresh. I know what I'm supposed to do, but I don't know how is the right way to do it. So now we can do this. Now we can just do, I'm making another method here just to be safe. It's going to be just call solve op. We need to give it int num1, int num2, and then the char of the operator. Which all this is going to be is this is going to be a nice little switch statement on our operator. And case of plus, I guess, first. We can just return num1 plus num2. So it's going to be plus. It's only plus the multiplication? Oh. Okay, well, I guess that solves that then. So I guess we technically didn't need to have a switch statement here. I'm going to leave it as a switch just in case we need to add on to this, but there we go. So now we can just do, we can simply, so this isn't going to be recursive. No, this is going to be recursive. So now we can just do, remainder is going to equal this operation. So it's going to equal, solve op of left, right, and then so solve the left and the right, and then we give it the operation, which is up there, okay, and then it's gonna be plus then the remainder as it is. I'm gonna throw a space in there just to keep things the same. So now then is the rest of it with our operation. There's remainder, and now we can just return solve of remainder. Okay. Actually, what we do need to do is we need to do if we need to make a check here at the very end of if s dot contains a plus. Actually, if it doesn't. So if s dot does not contain a plus and s dot contains a multiplication. So while it does not contain any of these, we can just return integer parseInt s. And that should be our ending case here. Okay, so now we have to deal with the parentheses. The parentheses are the next bit that we have to deal with. So parentheses get hard because you can have nested ones. Dealing with nested parentheses, I should have done a full-on tree. I shouldn't have done this. Okay, I think I might not want to do it. So I need to do a separate solve here, and it's going to be a solve paren. So we're going to be given a string here, and we need to just solve the immediate parenthesis it has. the parentheses are what's throwing me off. I'm doing this okay, but it's just the parentheses is what I don't know how to do. So when you call it solve paren, give it the remainder. What solve paren is going to do is it's going to solve the immediate parentheses. So we're going to do int end is going to be equal to 0. We're going to do so actually we're going to do int we're going to call this p count. It's going to be equal to 1. So we're going to do while here p count is greater than 0. We're going to run. We also need we do need to keep track at the end. And what we're going to do is we're going to do end plus plus, and then we're going to check if s dot char at end if it equals a closing parenthesis, we do p count minus minus. Otherwise, if it isn't open, we have to do plus plus, because again, we're trying to figure out where the parenthesis starts and parenthesis ends. So if we have nested ones, we need to account for nested ones. So this is how we're going to account for nested ones. So when we get to the end of this, we're going to have end at 0, or we're going to have the end of where our end index is, p counts, and we're going to do we're going to do string to process. So solve paren is actually just going to return a string back. It's not going to return an integer. It's going to have to process. It's going to be equal to s dot substring from 0 to end plus 1, because we want to go one more than that to get the whole string, so we don't want to exclude that one. And then we're going to have string rest is going to be equal to s dot substring. We're going to do a check here first that if n plus 1 is greater than or equal to s dot length, length is less than, sorry. If n is less than it, then we will go ahead and set rest to end plus 2. Sorry, n plus 2 to the end. So that's gonna be the rest of it. Cool. So there is the rest of the string. And then what we're gonna do is now we want to then solve this inner bit. So we have two process. We're actually gonna go from 1 to n. We don't care about the last one. We don't care about the last parenthesis. So that's why we're even removing it from here. I guess we could do plus 3, but whatever. And because we can call trim here too, just in case. And then we're going to solve to process. That's going to give us an int value is going to be equal to that, and then we're going to return value, which actually we can just put with solve plus rest. Hopefully this will solve the parentheses, so we can now just do string right is going to be the solve parenthesis, which that means we don't need to do this then. So we're going to solve, so we're the remainder, so we're going to solve the parenthesis. So all we can do is we just need to set remainder equal to that. So remainder should then solve it, come back, we should be good now. Okay. Okay, wait, this is actually going to get much better, because now we can call s here is going to equal solve paren, solve paren of s, which will then give us the left, so we don't need to do this. I think we can get away with just this, because we're just killing out the parentheses, and hopefully, and so we're going to just call solve s. YOLO, I don't know. Let's just see what this does. It ran, it didn't give any errors. Hold on, I didn't output. I didn't output. Did I just do this right? No. What? I'm solving to 18. Hello? Oh, I didn't give you the right file. Good job, me. There we go, that's what I was expecting. Number format exception for that. So we have the remainder here. We are substringing. So we're trying to parse the int of 0 to the space index. So we have this somehow messed up. This is the right, so the operator didn't get set correctly because I'm doing this too early. No. Yes, I'm doing that too early. Alright, I should be getting rid of S as soon as possible. Yeah, I should be doing this after. So once we do that with S, we should never be touching S again. Good. Index out of range exception of -1, so there's no more space. Space index is greater than 0. So there's no or. Equals -1. Oh, that works too. Now we got an index out of bounds here. Okay, let's do system out print line. Can I print out what it's trying to solve? Let's see where it's getting. So it's trying to solve 28 times. So it's doing this right? 14, 19. It is doing it right. That's actually really incredible to me. All right. So it's working. We're getting to 28 plus 9. So we're going to space index, S index of that, from 0 to the space index. So that's grabbing the left, which should be 28. Going over 1. Gets to the operator. There's no space index left. So we do need to do is greater than 0, which is the space index. Otherwise, we do remainder dot length -1. Please. Sorry, dot length, not -1. What? How? Wait, what? Operation. There's the right. Plus space remainder. Why is remainder still on 9? That's a problem. So it's going from substring the space index +1. Oh, I need to put this. I should just do this as another clause here. I should just do that. Make my life a lot easier. That's why it's doing that. Okay, please. There's a range exception. How do I deal with this? Let's just, actually we can just do this. We can just do a simple if statement here. If the space index is greater than 0, deal with it this way, which is going to be doing it like this. Actually, we can just deal with it like that. Okay, and then otherwise, it is the end of the string, so we can just do the right parse int rest of the substring, just parse int of remainder Remainder is now empty, so we just solve it and return. Actually, we just return this. So fingers crossed now. Cool. Okay. Okay, so we made some progress. So we solved the first one, so now we're on the second one. Here we're getting oh wait, is that line 2? Is that really line 2? What the heck happened here? Why is there... What the... Solve S. What? I'm so confused. Oh, print line. That's what's going wrong. There we go. Okay. So 5K. So it's trying to then solve the internal bits, which it is trying to do. So yes, that's right. And it's going to reach this, and it's going to solve the inside bit. Good, good, good. And then we get an issue where it goes to 21 times. We're missing a space, I'm guessing, when we come out of solve paren. When we're solving a parenthesis, we must not be giving it a space. So this is returning a string. So is it, do I just need to do this? Is that all I need to do? No. So I'm using spaces. I probably shouldn't be using spaces. I put that there instead. Why are we then trying to parse a remainder? Remainder is that. Yeah, it's trying to parse the entire thing. I want the space. Why is the space gone? How did we lose the space there? My trim must be screwing things over. This is where you would actually want to read to the next bit. I'm so close. Just remainder is messed. So it's just a print line of remainder. Yeah, so we get then, yeah, 16, 5, 21 times 2. No. Do we just get rid of spaces and make our life easier? I think we just get rid of spaces is what our solution here is. Just kill spaces. So we can just do s dot replace all spaces with nothing, k. All right, so this is going to be the first non-number. So we need to change these space indexes to not be space. We need to change them to be just nothing, if that makes sense, or to be the next non whatever. this is going to be, call this plus index, or call this next index plus. So we need to do a plus, or that's left, right. But we don't know how long this number is. Okay, so we just need to do that. Okay, this is fine. We'll do this differently. Let's just make a method down here. Public int read next number. Actually, it's a string. We're gonna do it this way. Take in the string str, and we're going to do int end is going to be 0, and we're going to do while while str char at end I don't know the ASCII table. What's the ASCII table off the top of my head for Java? What's the Java ASCII table? ASCII chart. I don't know the Java ASCII chart off the top of my head. That's not. Oh. 48. So we subtract, well, char at minus 48 is greater than 0. Or sorry, it's greater than or equal to 0, and minus 48 is less than 58, or not 10. Nope, less than 11. Wait. Minus 48 is greater than or equal to 0. Yes, less than 10. Okay. So while that's true, we're going to do end plus plus. Good. And then we're going to then return str substring from 0 to end. Okay, so that should now allow us to do left. Instead is going to be, so we just need to do string num of s. So now we can do that, and then we can do substring of num dot length there, and then we can set num here again to use remainder. We do need to do if end empty. That way we're going to turn empty. So we're going to just do if num is empty. Nope. If num is empty, but we check for not. If num is not empty, we go ahead and parse it, and then we do num dot length again. Cool. Now let's try this. Almost. Where is this index out of bounds exception at? Substring from 2 on. That was the left. Oh, that substring isn't what we want. Operation is just 1. So now we're getting parse num. My bad. So num is empty, so that means there is no right. So if num is empty, that means there is no right. Wait, what? Debugging is fun. What? What's rem here? Where's our operation? Okay, get rid of these trims. These trims are killing things too. You don't need trim anymore. Okay, so now we have rem, which is going to be that. So substring of the number length plus 1 is remainder. Char at 0, remainder. Substring 1 inclusive. Why? So after this, the first thing that should be here is the operator. Is it plus 2? No. That makes no sense. What? Oh, wait, why is it num.length plus 2? Okay, well, we're gonna leave it like that. So now we're at the operation. So let me, where are we at now? Where are we getting the next out of bounds at? 0 with here. So this is our operation. Print lining S, so we get our number. Yeah, wait, that makes no sense. Oh, we're skipping over it, aren't we? Just num.length. Ah, there we go. Okay. Let me switch. Okay, this is, okay. Let me switch to their examples. This is just going really slowly for me. Kind of bad. Let me switch to their example. So am I able to solve this? Index out of bounds exception. Ah, so wait, this read next number. String 1 on. That's off. Get rid of these trims. What the heck? Okay. So we're getting 65 plus 6, which is okay. Why are we struggling to read 65 plus 6? Let's do that. Let's do the remainder after we remove. Let's do this. Debugging is fun. Why am I failing? So remove the operation. We can do that. Okay. So plus 6 is right, and then 6. Oh. While end is less than str dot length. Sorry, that's also why. We're going too far. And we get 71. Is 71 the answer for this example? It is. Okay. Let's throw back our inputs in. Let's see. Do we get this to parse? Almost. Oh, wow. Okay, so I needed to use longs, apparently. Okay. Well, that's annoying. So I need to make these all longs. Left, right, right. Long, long, long. Yeah. Apparently I just need to use longs. Long. Parse long. Okay, maybe. Okay, so good. But for some reason you took out, because you're going +2 here. That's why. Okay. I think we're good now. Let's just try, let's just do it. Let's just go through. Okay, so we're gonna have a long answer here. We're sort of 0. It is asking us what? Becomes, okay, before you can help with the homework, you need to, was a sum of the resulting values. Okay. So we're just going to do answer plus equals solve. Plus equals, and then just a lap answer. Please be right. Please be right. Please be right. Please be right. Yes! Okay, that goes way longer than it should have, but we got it. Alright, part 2. You manage to answer the child's questions and they finish their part 1 of their homework, but they get stuck when they reach the next section. Advanced math. Now, for advanced multiplication have different precedence levels, but they're not the ones you're familiar with. Instead, the addition is evaluated before multiplication. Oh. So it's left to right, but we do addition before multiplication. Okay. So we should do this. We should still have this method basically be the same, but instead we're going to call this solve ADD or solve add. And we need to solve all of the addition first. I guess no. So we're gonna do the same exact thing, but we're gonna have 2 different methods here, just so that way I can do part 1, part 2. So there's our solve. So now our solve addition. So now we need to prioritize addition over multiplication. So for prioritizing addition over multiplication, what we need to do is we need to check the operator, and then if the operator is a multiplication, we need to skip it. Oh, this would have been better now if we had done the tree correctly. If we had correctly broken this up into a tree, I would have done so much better. I should have done that. So yeah, so solve parenthesis, all solve parenthesis does is just calls solve. So we need, oh, this is gonna be, we're gonna need another one of these, aren't we? We're gonna need a different one of these, so that way we can call a solve paren, but a solve paren of add. That way this can call solve add. Okay, so we have the operator. I did this wrong. I did this wrong. I don't know if I can get part 2 because I did this too wrong. I didn't do this correct and I didn't do it the right way. So what we need to do is we need to go to every addition first. We need to go through, solve the additions where possible, and then solve multiplication. Okay, so I might have to do this different. So we might be ended up doing this again, just differently. So we're gonna call solve add. Since this is all the same as what it was, I'm just gonna delete it so we can do it again. So what we're first gonna do is we're first going to do s, and we're going to search for contains a parenthesis. If it contains open parenthesis, actually we're going to do int it's going to be s dot index of this. So what we're going to do is we're going to solve this. We're going to call that. Okay, so we're going to have, so we have the open index. We're going to then call solve paren add of s dot substring from op index on, because solve paren add is just going to solve that specific bit there. So we can just then do s is going to equal s dot substring from 0 to open index with the rest on it. So now we've solved that. So in theory, after this, we have finished solving all of the parentheses first. Now there's no more parentheses to solve. Whoops. So good. So now there's no more parentheses. So now we go ahead and do is we search for all of the addition fields first. Actually, we're gonna this be in a while. Sorry. We want to solve all of the parentheses first. Okay, and then we're gonna do the exact same thing just for addition here. So this is gonna be the plus index, plus index, plus index, k. And instead we're gonna do is we're going to, we have the index of the plus, so we're technically going from left to right. So what we need to do is we need to do left is going to equal s dot substring from, ooh, we're going to need to solve, but backwards. But what we can do is, because we're solving this way, what we can do is we can just we call read next and we call read last. Let's do that. String, and then we're gonna start at index here. So we have our index that we're ending at. So we have end. So we actually want to do start equals index, while start is greater than 0. While start is greater than or equal to 0. Nope. We're gonna do start minus minus. Okay. Char start minus minus, and then we're gonna call here if this should never happen. We should always have a number here. It should never have an operator by itself, and we can just go ahead and just do start to index. Okay. So now we have a read last, so we can go up here and we can just do left is going to equal read last number. We're going to give it s, and we're going to give it the plus index. Cool. Oh, it's print a string. Okay. And now we can do the right as the opposite. So now we can do read next number. This one needs to take an index as well. That way we can have a starting index bit. So n is going to equal index, right, less, there, and we're going to substring from index there. Cool. All right, so now that those both should work, so now we should have read next number there, and so do that, and we can just then do s dot s equals s. Actually, s is going to equal s dot substring of plus index minus left dot length, I think. And then we're going to do this for the length of this plus 1 for the operator plus right dot length. Oh wait, sorry. Sorry, from plus index. Sorry, we're gonna go from 0 to this, my bad. From 0 to that, then we're going to add solve. We're just gonna do this manually. Actually, no. No, yeah, we're gonna do the manually. We're gonna do integer parse int of left plus integer parse int of right. These need to be, sorry, longs. I messed that up. I'll do it in a second here. And then go on for s dot substring from this on. Wow, that's a something line. Okay, these need to be changed to be long. Parse long, right? Because again, longs, not ints. Okay. So plus is solve first. Good. And then now we just go from right to left, solving so again, we're just gonna go literally right to left, solving this. Okay. So this is actually going to get easier because we can just do left is simple. We still need right, but it's going to be 0 to plus index and then long parse int s dot substring 0 to plus index. Oh, right, no. Yes, that doesn't go there. That's what we're missing. Okay, parse of right, and then parse of substring 1 plus that. Okay. Oh, we still need the left. S substring, we're going to go from, we're only going to take it from, oh, we don't need, okay, we don't need, it's going to be a substring of right index plus index. Okay. And that, okay. So what's wrong here? Substring from 0 is the index is out of bounds. What? How is that index out of bounds? And then here we're just going to return long parse long of s. And actually, we don't need to parse these longs. We can just keep them as strings. Oh wait, we do need to. Sorry, we do need to do the math on them. Never mind. Never mind. All right. 0, 0. Okay. And we're gonna do this again, but this time we're gonna have answer 0, but we're gonna call solve add. I don't know what to expect here. Formula for empty string. Okay, so I must not be doing this right. So this is probably just wrong. So we're going from 0 to 0 to plus index. Oh, minus the left length, right. What's the input string? So either left or right is empty. So I'm gonna guess that right is empty. So let's just do system. What is S here? Print line. Don't do that. Ah, okay. I'm gonna guess it's going to be read last is not working. So we're starting index. So I'm gonna say it's the first one. So we're starting index. Does that is greater than minus? We'll start is greater than 0. Substring from start to index. This is what's failing, is read last number. So we should starting at 1. 1's greater than 0. Go back. Oh, index minus 1. Or not. Well, that didn't help at all. Okay, so I'm at the system out print line left and right here. And right. So what am I messing up on here? Please tell me. Ah, right is empty. Ah, read. Okay, so I should be doing this. Let's do this. So read next and last. Don't do minus. Let's do these manually ourselves. Minus 1, plus 1, plus 1. There we go. That should fix that issue. Or not. But this should still... Oh. So this one we can't. Okay. Please just work. Cool. And then we index out a range exception here. So why do we have... It does not equal 1. So that means we have a... that. Oh, because we're using plus index and we should be using mults index. That's that issue. Sweet. Okay. So now we got to here. We're having an issue with left for some reason has a multiplication on it. Okay. My guess is we're reading. We start at minus 1. Oh. So we do need to call plus 1 on because yeah, this should be exclusive. What is this? Okay, so when it first goes wrong, all right, okay, so it solved that. Okay, so now it's the left side is 16, 13, 9 plus 4 is incorrect. It should not be 9 plus 4. Left length. Oh, we need string begin. This is what we're missing. So here's the beginning. So we need substring at the beginning length plus all these. That's where we're going wrong. Out of curiosity, did I just somehow get it right? Just nope. Okay. Just out of curiosity, just to make sure. Is it still asking about part 2? Apples are also the valuing homework. Okay, yeah. So let's do some individuals here. I get 205, which should be 51. So 5 plus 6, so does that first right. And then it's 1 plus 53. Okay, well that's not right. What? Oh, hold on. The multiplication is probably wrong too, isn't it? This is probably wrong as well. Oh no, this doesn't need to be. So if we're doing multiplication, multiple index, well, one that should be multiplying, by the way. Let me do. This is all just debugging to figure out where my problem is going wrong. Literally is all that's left right now. Determine where this is going wrong. Okay, what is what I'm doing? So 6, 11, 44, 64, 44. So this is the S. So 4 times 11 is 44. What's going wrong? Four times 11. Oh, we're not going far enough over. There we go. String manipulation is a killer sometimes. Alright. Put this back to our input. Maybe now we'll get it right. Hey, we did it. Okay. Wow. That was a really long amount of work. This wasn't... I'm not sure if I'm going to say this was hard. It's not hard if you're like me and you know what you're supposed to be doing. Had I done this 2 years ago, I would have gotten this so much quicker. Because this is one thing they do teach you in college, for me, at least from my college courses, is parsing like this. Parsing is a big part of the classwork that you do, and parsing stuff like this would have been something I would have probably been in tune with, but it's been 2 years since I've done that. And while I know it's the tree structuring of the trees, yeah, knowing the kind of the more fine stuff of the correct parsing strategy and all that was not in my head, and of course I'm trying to do this quickly. So yeah. Okay, so to explain this one, I'm going to more explain the theory about this. Again, it's been a few years since I've done this. The goal of what you're doing is you're just trying to build a binary tree of your expression to then evaluate. So in this first one, we're trying to build a binary tree of this to know that we want to solve 5 plus 9 first, and then add this to this, and then add this to 9. A diagram would be very helpful, but you can think of this as the lowest leaf nodes is going to be 5 and 9, and between them is going to be a plus, and then onto that is going to be the plus, and then the other leaf node is going to be a 5 with the parent of those, so it would be another plus, and then the parent of all of that is going to be a plus with a leaf node of 9, and at the very end there's going to be a parent node of multiplication and then a leaf node 9. Look into expression trees if you want to know more about how to do this. That's basically the key to solving this, is expression trees. I didn't quite do that. Again, it's been a while and I'm trying to do this quickly, so doing these the right way doesn't necessarily come out right away, but key to this is expression trees. Generating your expression tree for your given rule set is what you're going for. I would explain it more, but I don't want to explain it incorrectly, and it's too late for me to kind of just quickly Google and come back up to this. So that's the key for solving this, is expression trees. Building an expression tree, solving an expression tree will give you your answer really quickly. And yeah, so anyways, hope you guys enjoyed. I'll see you guys tomorrow for day 19. Peace out.